Steel Authority of India Limited (SAIL) is the largest public sector steel producer in the country, which produces a wide variety of steel products at its state-of-the-art integrated steel plants across the country. After its modernization and expansion program, SAIL has a production capacity of about 2 million tons of structural steel, which makes structural steel an important contributor to the company's bottom line. Architects and builders are using structural steel to make buildings lighter, economical, safe, sturdy, and aesthetic in today's time and age. Such steel sections are replacing concrete sections due to their time-saving construction, as well as high strength-to-weight ratio. The high-rise structures today are constructed mostly using structural steel. Structural steel sections are a category of steel that are produced in a particular cross-section or shape and have specified chemical composition and mechanical properties for use in structural work. The shapes, sizes, composition, strengths, etc. of such sections are regulated by standards in most industrialized countries. Broadly, rolled structural sections are categorized into three types: angles, beams or joists, and channels. In India, BIS codes regulating the nominal dimensions, mass and sectional properties of hot-rolled structural steel sections are IS 808-1989 for angles, channels and tapered flange beams, IS 12778-2004 for parallel flange beams and columns. Angle section. An angle section consists of two flanges, legs perpendicular to each other. They are available in a wide range of sizes in terms of their leg lengths and thicknesses. The legs can be equal or unequal depending on the requirement. Angles are designated by the length of their legs and the thickness of the leg. For example, 50 by 50 by 6 represents an equal angle with leg length of 50 mm each and thickness of leg of 6 mm. Under IS 808-1989, angles are classified into two types, namely Indian Standard Equal Angles and Indian Standard Unequal Angles, both being designated as ISA. Angles are therefore widely used in a structural design as axially loaded members, especially as bracing members. In a typical building construction, their usage as wall panel framing members and stiffeners in plated construction also is quite common, effective and efficient. SAIL can produce equal angles in the size range 50 by 50 by 5 mm to 200 by 200 by 25 mm with sectional weights ranging from 3.8 kilograms to 73.9 kilograms per meter. Channel section. A channel is a hot-rolled steel section having a vertical web joining the top and bottom horizontal flanges with inside radius corners. Channels are designated by their abbreviation and the depth of the section. For example, ISMC 75 or MC 75 represents channel with depth of 75 mm. In some cases, the channels are designated by the depth and flange width, such as 75 by 40 mm. The flanges separated through a web render the section a reasonable moment of inertia and section modulus. But due to lack of symmetry about the minor axis, the shear center of such section lies outside the section, which in turn makes the section unsuitable for carrying loads and bending moment about its major axis for a longer span unless the section is effectively restrained against torsion. But combining two such sections using suitable battens, lacing or bracing, if the missing axis of symmetry in the resulting section is restored and can be used as significant load-bearing member in a structure. SAIL can produce ISMC 75 to 400 as per IS 808-1989 and UPN U section 200 to 400 as per DIN 1026. Beam section. This section consists of two flanges connected by a web at the center, like an eye or H. Presently, two types of rolled beams are available, that is, beams having tapered flange sections, that is, whose inside flange surface is tapered, and beams having parallel flange sections, that is, whose inside flange surface is parallel to outside flange surface. Beams with tapered flange sections are covered under IS 808-1989 and beams with parallel flange sections are covered under IS 12778-2004. Under IS 808-1989, beams are classified into 4 classifications, namely Indian Standard Junior Beam, IS-JB or JB, Indian Standard Lightweight Beams, ISLB or LB, Indian Standard Medium Weight Beams, ISMB or MB, and Indian Standard Wide Flange Beams, ISWB or WB. Tapered beams are designated by their abbreviation and the depth of the section. For example, ISMB 100 or MB 100 represents beam with depth of 100 mm.
SAIL can produce MB of depth 100 to 600 mm.
Under IS 12778-2004, beam sections are classified into 2 classifications, namely Indian Standard Narrow Parallel Flange Beams, ISNPB or NPB, and Indian Standard Wide Parallel Flange Beams, ISWPB or WPB. Narrow parallel flange beams are doubly symmetric shapes, generally used as beams whose inside flange surfaces are substantially parallel to outside flange surface. Beams under this standard have flange widths generally lower than the depth. These beams are designated by their abbreviation. The nominal depth and nominal flange width and mass of the section in kilogram per meter. For instance, NPB 160 by 80 by 15.77 means a nominal depth of 160 mm and a nominal flange width of 80 mm with mass of 15.77 kilograms per meter. Wide parallel flange beams WPB with nominal depth up to 300 mm have nominal flange widths same as nominal depth of the beam. For WPB with nominal depth above 300 mm have nominal flange widths of 300 to 400 mm. Similar to NPB, WPB are also designated by their abbreviation. The nominal depth and nominal flange width and mass of this section in kilogram per meter, for example, WPB 160 by 160 by 23.83. NPBs are generally used in beam sections, that is, horizontal members carrying transverse load, whereas WPBs are generally used in column sections, that is, vertical member carrying axial load. Due to emphasis on economical use of steel in construction and better sectional properties, parallel flange sections are being preferred. SAIL produces parallel flange sections at its state-of-the-art universal mills at ISP Burnpur and MSM Durgapur. SAIL produces NPB of 100 to 750 mm depth and WPB of 100 to 450 mm depth. SAIL can produce structurals with chemical composition and mechanical properties as per IS 2062-2011. SAIL can also produce structurals as per various foreign specifications such as ASTM A36, JIS G3101, SS 400, etc.
When a structural engineer chooses a structural section of given depth D1 and flange width D2, and sectional weight or mass in kilogram per meter, along with this choice, he automatically chooses the sectional properties like area, web thickness, flange thickness, root radius, moment of inertia, radius of gyration, section modulus, plastic section modulus.
A structural engineer has to consider the loads and stresses that the structure building being built will have to withstand and the mass and sectional properties, that is, moment of inertia, measure of cross-sectional stiffness, modulus of section measure of strength of a beam, radius of gyration, measure of a column's resistance to buckling about an axis, etc., of different structural steel available before deciding on the appropriate structural steel to be used in the construction.
Previously, SAIL used to produce tapered beams of few dimensions only.
Now, with the setting up of new universal mills at USM Burnpur and MSM Durgapur, it will be possible to produce NPB and WPB beams of various sectional weight. Advantages of parallel flange sections NPB, WPB over tapered flange sections MB are that flanges in parallel flange sections allow efficient distribution of material in the cross-section, which results in higher section modulus. NPB has a lower mass for the same section modulus about axis. This means that it can carry more load with lower weight. When used as bending member, parallel flange sections offer 15 to 30% saving in material. WPB section is more efficient in terms of compression as it has a higher radius of gyration which can withstand buckling to a greater extent. It can lead to 30 to 40% saving of material over tapered sections. Parallel flange sections are more efficient in terms of strength, workability, and economy. Connections are far simpler in parallel flange sections. Connections to flanges can be done by direct bolting without tapered washer. Butt welding of plate at the edge of parallel flange section is easier. In case of tapered flange sections, only small-sized welds are possible between the cover plate and the flange tip.
Moreover, proper welding between surfaces at such obtuse angles is difficult.
In case of parallel flange beams, especially with respect to Sale's new mills with universal rolling technology, more number of beams having same beam depth but varying flange with web thickness, flange widths and weight per unit length will be available. This will give more flexibility to designers and economy to the owner to choose the most appropriate section.
Structurals can also be fabricated from plates by welding. The advantages of parallel flange sections, NPBs and WPBs over fabricated sections are: residual stresses developed due to welding are minimized.
Greater savings due to lesser fabrication costs and lesser construction time. Better quality of finished product due to universal rolling technology and also lesser dependency on workmanship and welding quality. Structural steel differs from concrete in its attributed compressive strength as well as tensile strength. Structural steel is one of the most commonly used materials in commercial and industrial building construction. Also, steel has high strength, stiffness, toughness, ductile properties and is environmental friendly due to being recyclable in nature. Depending on the scale of construction, steel-based buildings take 20 to 40% less time to be constructed. Structural steel can be developed into nearly any shape, which are either bolted or welded together in construction. Structural steel can be erected as soon as the materials are delivered on site, making steel a schedule-friendly construction material. This reduces the site management cost by about 30% and overall building cost by 3 to 4%. Since steel sections in buildings are generally well exposed, they have relatively less crack propagation. If at all faults like cracks and corrosion are there, they can be easily identified and repaired. In addition to this, steel is inherently a non-combustible material. The most important aspect of steel construction is that it is aesthetically appealing and can be changed or replaced very easily during the initial phases of construction.
By virtue of all these attributes, structural steel will be the future of construction industry, and SAIL, having established its new mills, is fully geared up to meet this demand.